And it is now time to our next and final key note speech for today, which will be, we have Dr. Mohamed, I think, ready? Yeah. We have a talk about the current and the evolving landscape of requirements engineering in practice. Our speaker is Dr. Mohamed Hassan Kassab. He is the Associate Professor of Software Engineering at the Pennsylvania State University in USA. Welcome, Dr. Mohamed.
Hello, everyone. Can you hear me?
Yeah, we hear you, and your slides are on screen, so please just...
Perfect. So it's my pleasure to be invited to speak at the Federated African Middle East Conference on Software Engineering. A little bit about myself. I'm currently an associate professor in software engineering at Penn State, and my research evolved around requirements engineering, software architecture, and bridging the gap between disruptive technologies and software engineering. In the past years, I've been exploring requirements engineering and how requirements engineering has been challenged in the recent years and how disruptive technologies could impact requirements engineering. So for today, I'll be speaking about the current and evolving landscape of requirements engineering in practice over the years. So 40 years after the requirements engineering was acknowledged for the first time as an independent discipline in an issue in the transactions of software engineering, a large portion of everyday industrial practices is still dominated by conventional wisdom rather than by empirical evidence. And even though there is a big amount of information available on solid requirements engineering practices in software engineering, some evidence still indicate poor practices in industry. So, for example, a study of corporate IT projects performed by IAG Consulting indicates that the companies surveyed, about 2/3 of them classified their projects as likely to be failure. And the most frequently cited reason for failure by respondents was poor requirements gathering techniques. So there are few challenges, there are some challenges to requirements engineering discipline in the recent years. One challenge is that we are leaning to bigger teams, to bigger projects, and the demands for bigger and more complex systems have resulted in the tremendous growth in the size of the teams tasked with developing them. The technical infrastructure supporting software developers has evolved to a degree that development teams can now be physically distributed across the globe. Professor Thomas Allen developed what has come to be known as the Allen curve that you see on the screen to describe the effect of physical distance on human communication. So Allen's experiments have shown that the increasing distance, the physical distance between employees from 5 meters to 20 meters results in 3.5 times reduction in the probability of weekly communication between the employees. His work has demonstrated that co-allocation of project teams continues to offer the most efficient and effective method of reaching team cohesion. The second challenge is with Agile. So with the increasing popularity of Agile approaches, requirements engineering discipline was challenged under the Agile umbrella. This is basically true because doing requirements requires spending more time studying the business and application world and less time programming. Doing requirements takes time that could be spent writing code, and users often feel better if they think that people are working, that is, coding on their problems. In fact, ever since Agile was emerged in the 1990s, there has been debate about what role requirements engineering can play for Agile practitioners and their customers. So the increasing adoption of Agile practices in software development challenges the need for describing software requirements upfront, which industry practitioners consider as a moving target. Some practical evidence, furthermore, could indicate that specifying requirements can hinder creativity and design because designers become overly preoccupied with the information provided. And the third challenge I want to talk about in requirements engineering is dealing with non-functional requirements. So software systems are characterized by both functional requirements, what the system does, and non-functional requirements, which is how the system would behave in respect to certain observable attributes, like security, performance, reliability. And in software marketplace, in which functional equivalent products compete for the same customers, non-functional requirements becomes more important to distinguish among competing products. Yet, in many software engineering processes, in practice, non-functional requirements tend to be ignored till later in the process. But because of that, some of the software engineering principles can be compromised. So the challenge here is, first, there is no consensus among the software engineering community on how to define these type of requirements. There are some agreement on how to define the term functional requirements, but if we look at the literature, we find that there is no consensus on how to define the term non-functional requirements. So in one book titled Non-Functional Requirements in Software Engineering, the authors listed 161 types of non-functional requirements just to give the reader an idea about the areas that could be covered by these requirements, and this is not even a complete list. The IEEE 600.12, which is the standard for software engineering terminology, does not define this term, and the literature refer to these terms as aspects, attributes, properties, criteria, utilities, and NIS. So there is no agreement how to define these requirements, but nevertheless, ignoring these requirements can lead to catastrophic project failures. In this list, I'm just listing few of these classical cases in software engineering of failures in projects because of ignorance in non-functional requirements. Mars Climate Orbiter was a classic case, and this was one of two NASA spacecraft in the Mars Surveyor 1998 program. The mission failed because of software interoperability issue. The craft drifted, of course, during its voyage to Mars and entered a much lower orbit than planned and was destroyed by atmospheric friction. So the metric imperial mix-up, which destroyed the craft, was caused by a software error back on Earth. The ground software used English units, while flight software used metric units, caused by position calculation error. And these two software both developed by two different companies, and that was a loss of $350 million and 3.5 years loss on time. FAMECSE 25, it's a classic case also of failure. This is a medical linear accelerator, and this was a radiation therapy machine. It was involved with at least 6 accidents between 1985 and 1987, in which patients were given massive doses of radiation, and sometimes 100 times more than the intended dose. 3 to 6 patients died as a direct consequence. These accidents highlighted the danger of software control of safety-critical systems, and they have become standard case study in health informatics. The software was developed here by a single person using BDB-11 assembly language over a period of several years. And the software evolved from FAMECSE 6 software, which started in 1972. The program structure and certain subroutines were carried over to the FAMECSE 25 around 1976. So it appears that unit and software testing was minimal, with most effort directed at the integrated system test. Target systems was also a recent case where actually Target credit cards stored on point of sale by Target system. Target is a mega store in the United States, and 40 million credit cards were stolen. So the Target system were compromised by stolen passwords. An HVAC company had access to their networks in order to monitor the systems, and the preparators were then able to gain an access to the systems by installing a malware on the point of sale. And the malware was able to steal 40 million credit cards in only 2 weeks and a half, and my credit card actually was one of them. So there is no agreement on how to define the term non-functional requirement. So this is a challenge to requirements engineering, but ignoring these requirements can lead to classic failures. And non-functional requirements have been specified at best in loose, fuzzy terms, and each domain and each community can create their own term. So, in fact, in a book called Software Architecture in Practice, the authors refer to a quality requirement that deal with a system. This system was developed in Iowa. Iowa is a Midwest state, and it's not very attractive for young developers to relocate there. And the software had to be attractive enough for young developers to move to the region and work on the software. So the authors couldn't really find a term to refer to this quality requirement, but only Iowability. So good luck trying to find this term in any taxonomy for quality requirements. And in recent research, we've also examined two emerging quality requirements in the context of Internet of Things. One, when Internet of Things is being deployed in healthcare, and we looked at caring quality requirement. And we also looked at humanization quality requirement when Internet of Things will be deployed in education domain. So the idea behind this slide is that there is no consensus among the software engineering community and practitioners on how to refer to these type of requirements. Another challenge to requirements engineering is a problem of traceability. Research indicates that there is a gap between requirements engineering and solution space, and the gap is a problem of traceability. And tracing requirements is a challenge, but tracing non-functional requirements even poses more challenge because these requirements can manifest themselves across different modules when they are mapped from the requirements domain to the solution space. And these requirements tend to be interact in the sense that attempt to achieve one requirement like security can help or hinder the achievement of other requirements like performance. And another challenge to requirements engineering discipline comes to the effort estimation. So with that, we understand like there are different models on how to estimate the size and the effort of requirements, but how to estimate the size and effort of non-functional requirements. According to a report by IBM, these requirements can be up to the 50% of the total effort of building the software, the effort of building the software. We know that effort is a function of size, but do the non-functional requirements contribute to the size? And if so, how to measure the size of these type of requirements? In fact, in this slide, I'm showing some data that extracted from a repository, from completed projects from financial institutions in Finland. And in the figure, the circles point out some projects where the one in the right had a larger functional size measured in function points with lower little effort measured in person hours in comparison to the one on the left. And in the same figure, the square points has similar scenario. So in this case, it's an illustration that in addition to the size, the relationship between size and effort is actually not linear. Other factors contribute to that, and these, in fact, non-functional requirements. So to this end, and to pave the road for the industrial adoption of requirements engineering research contributions, there is a need to close the knowledge gap between the practices in industry and the results from the research. The key issue in improving requirements engineering industrial practices is to first identify the areas that need most improvement. An exploratory survey of software industry professionals is an effective empirical instrument to determine the state of practice in software engineering. And at Penn State, we've been involved with exploring software engineering state of practices, and requirements engineering was one of the areas that we examined. So over the years, we've constructed 4 international surveys that recruited participants and practitioners from around the world. In 2003 was the first survey, and the results presented a comprehensive indication of the requirements engineering practices in industry at that time, and the results indicated at that time that various techniques associated with agile development were not widely employed back then at that time, as the waterfall had been dominating the landscape and the development practices. And the survey results at that time were highly cited and seemed to provide the template for more focused requirement surveying. This survey was replicated in 2008, and the results from that survey indicated that there was the findings from 2003 remained largely unchanged. In 2013, we updated and revised the format 2 surveys, and we conducted an exploratory survey at that time that recruited more than 1,000 software professionals. And while the rise of agile methods and their joining practices could be observed in 2013 results, some techniques like requirements inspection, effort estimation, and prototyping has still not risen to the dominance as what we had expected. So motivated by understanding the changing landscape of requirements engineering set of practice within the software engineering context over the past years, and to provide useful data to the researchers, we conducted it at the end of 2020, beginning of 2021, a 4th survey to examine the recent trends in the requirements engineering set of practices and how these have changed over the years. So in the remaining slides of this presentation, that's basically what I'll be covering. So in this slide, we're providing a list if you would be interested in how the methodology for these surveys were conducted, or information about the project's characteristics or participants' characteristics from these surveys. So these data are available, and you're invited basically to even replicate these studies at different locations if you prefer. So the first finding I want to talk about is regarding the software engineering life cycle. As software development has evolved into more mature engineering discipline, often involving distributed teams, and the techniques and frameworks has used also evolved. When asked which software development life cycle this best describes the one used in the projects, 51% of the most recent survey reported using more than one approach. And agile methodologies, Scrum, extreme programming, feature-driven development were dominating the landscape, as they were selected in 70% of the surveyed projects. And this is an increase of 24% from the last 2013 survey. The waterfall maintained its presence still at the same level in 2013 as in 2013. Nevertheless, recent studies show that companies often don't use only agile methods, but rather like a hybrid development approaches that mix agile and plan-based methods like waterfall to combine the benefits of both approaches. So in fact, around 13% of the overall sample reported using a hybrid approach, mixing waterfall and agile. Further analysis linked the question on which software development lifecycle being selected to the project domain. And we observed the presence of agile approaches surpassing waterfall in every domain. And we also, in comparison to the data from 2013, we witnessed a shift in some industries like financial, banking, insurance, and defense and aerospace. Back then, in 2013, waterfall was more dominating than agile in these domains. So in the recent survey, we witnessed a shift in these domains, and we witnessed agile approaches are being practiced now more. So given the agile seeming popularity, and noting that prototyping is known as a popular technique to engage customers and end users to facilitate agile software development, the response to the question, within the life cycle, did you do any prototyping, was important to ask. The data from 2020 survey shows no changes in using prototyping. In 2020, it was 73%. In 2013, it was 72%. Of course, there are different interpretations of prototyping. For example, One interpretation is that prototyping is preliminary attempt at a solution that is progressively amended, abandoned, and refined as development progresses, often termed as evolutionary prototyping. So evolutionary prototyping was reported at 33%. Another interpretation of prototyping is a hastily constructed proof of concept that's subsequently thrown away. So it's usually called thrown away prototype, and this is reported as 17%. Overall, the use of prototyping was not much of different in agile projects than waterfall. So regarding the requirements elicitation techniques, in the 4 editions of the surveys, an average of 3 elicitation techniques were selected per project. The data from the most recent survey, it's the one that you see on this slide, revealed that brainstorming was the most common approach used for elicitation. While 2013 survey reported the same observation, it was also noted a declining trend of use cases usages back then from the first 2 editions of the surveys. So if we compare this from the most recent survey, the one that you see, we can observe a shift in this trend with the increasing popularity of use cases. This is interesting. So a paper titled Agile Methodology and Requirements Engineering by Bose and other authors recommended that projects using Agile should learn from various elicitation techniques that have been in use in the conventional approaches as waterfall. So our interpretation is that we indeed observe that in the recent survey, we see some usages of some techniques already popular in waterfall to find their way into Agile. Use cases and interviews, originally popular techniques for the waterfall model, are becoming common techniques in Agile projects as well. But also it's quite interesting to see the opposite also holds true. That even that user stories were developed specifically for Agile, it's finding its way to projects that have been declared as only waterfall. Within the Agile projects alone, user stories actually witnessed its biggest spike over the years. So currently within Agile projects, user stories are being used as a technique 43% in comparison to 14% in 2013. So the next question dealt with the requirements representation. So when the requirements are captured, how the requirements being written. So the majority of participants, about 69%, still report that requirements are expressed in terms of natural languages, and this number represents an increase from the last years. So in 2013, we see that a survey from back then, 61% reported expressing their requirements in natural language. In addition, we also observed that almost no change in reporting the usage of semi-formal notation like UML, despite its increasing popularity within Agile. It's also of an interest that while formal specification techniques still not commonly utilized for requirements specification, their usages witnessed an increase. Now it's at 12% in comparison of less than 1% back in 2003. So an interesting discipline in requirements engineering is requirements inspection. And the majority of respondents in 2020, about 50%, reported performing some requirements inspection, with a slight decline since the last surveys. And while 57% of Agile projects reported conducting some inspection in comparison to 60% of waterfall, both approaches were close in their preferences for the inspection techniques, with team reviews taking the first place and automated requirements inspection using tools remaining largely unpopular technique. The question on requirements estimation was only introduced in 2013 survey, and while 60% back then reported performing some requirements estimation activity, this number has slightly increased in 2020 to 65%. And story points became a popular technique, the most popular technique in 2020. Interestingly, story points was also present with waterfall projects. 70% of these projects reported using story points to effort estimate the requirements. And function points and COCOMO techniques remain unpopular techniques in both Agile and waterfall, as in the previous years as well. It's quite interesting to find out the majority of respondents reported consideration for non-functional requirements during effort estimation, 87%. And this percentage was consistent among Agile and waterfall. And this is interesting finding, considering the common belief that Agile approaches tend to deal less with non-functional requirements in comparison with waterfall. One reason for this belief is that non-functional requirements are not always apparent when the requirements are presented in user stories. So we further link the question of estimation techniques to whether the duration of the project was within schedule and within budget. Overall, we observed that when the project relied more on story points and group estimation techniques, there was a higher level of agreement that it's maintained within schedule and budget. Since waterfall projects reported more reliance on experts' judgment in comparison to Agile projects, which reported more reliance on group estimation and story points, it was interesting to find a higher level of satisfaction in Agile projects that the project was maintained on budget and within schedule in comparison of waterfall. Regarding the tools usages in the requirements engineering, overall, 49% of respondents reported that a tool was used to manage requirements. The usage of requirements engineering tools in Agile was 1.5 times more popular than in waterfall. This was an interesting observation, especially in the light of the common belief that Agile and requirements engineering tools may appear incompatible. While both involve the management of processes, their approaches differ in many ways. Agile promotes flexibility and rapid accommodation to change, while requirements engineering tools are based on tightly controlled processes that don't necessarily adapt well to changing business needs and requirements. Anyway, the most reported usages was for tools was for Confluence and Jira, 38%, followed by IBM Doors, 18%, followed by MS Office applications for 13%, as a tool to host requirements, to manage the requirements, changes, and so on. So we also looked at requirements engineering for small businesses. So we paid closer attention to how requirements engineering is practiced in small businesses where the companies had 1 employee or less. And we understand that the requirements engineering community has mostly overlooked the small businesses' characteristics and their requirements engineering practices, despite that the requirements engineering for these businesses mean really the success or failure for the overall small company survivability. So at a first look, for the small businesses, 35% of this subsample, we observe wide diversity. So this small businesses comprise 35% of the overall sample. But in that subsample, we observe a wide diversity in the employed requirements engineering practices for small businesses. And we can rationalize that the diversity is the result of the evolutionary adaptation as these businesses have to adapt to their particular ecological niche. And the context of these businesses is the essence of their adopted practices. So despite the diversity, in the second observation, we noticed that when requirements engineering practices are employed, then there is a tendency to adopt easy, flexible, inexpensive techniques. So the majority of these businesses, for example, opted for open source requirements engineering management tools. And a third observation is the high degree of cultural cohesion that the small businesses exhibit, with the majority of responses reporting an agreement that the team size was enough, sufficient for the requirements engineering challenges, and an agreement that the ability and previous software development experiences of the software development team was sufficient. So this high level of agreement may imply a homogeneity in the professional environment of the analyzed sample, which contributes to the efficiency in the communication and sharing and understanding of the requirements within the small business. So what are some of the takeaways from these surveys? So to conclude, I would like to give you like 5 takeaways. The first takeaway, so overall, the trend over the years showed that the requirements engineering practices in general within the projects had slightly maybe lost some satisfaction in the last years in comparison to 2013. So 82% reported satisfaction with regard to requirements engineering practices in general, in comparison to 70% in 2020. Despite this decline, the satisfaction level is still higher with what had been reported in the first 2 editions of the survey. The second takeaway, that number of areas and regarding requirements engineering showed no significant changes over the years. And this is in particular with respect to requirements inspection, prototyping, and utilizing semi-formal notations to represent requirements like UML. Third takeaway, while the 2013 survey indicated a significant budget and schedule performance issues, the data from 2020 survey indicated improvement in the overall performance in maintaining the duration of the project within schedule and cost within the budget. There are obviously many factors at work here, including the changing landscape of the employed estimation techniques from expert judgment to story points and group estimation, like what I mentioned, which are analytically proven to be more reliable, and the increasing rise of agile approaches that come with more pressures placed on development project timelines and budgets in comparison to the conventional waterfall approach. The fourth takeaway, along with the same vein, we noticed that agile projects outperformed the waterfall projects in the recent survey in maintaining the projects within budget and schedule. On the other hand, respondents from the recent survey expressed a very comparable level of satisfaction regarding the applied requirements engineering practices in their agile projects compared to the waterfall. And the last takeaway, that formal methods, whether it's expressing requirements in formal techniques or formal inspections or applying formal estimation techniques, remain largely not utilized in practice when dealing with requirements. So we posted the details of all the questions, all the data from these 4 surveys along the link. I have just co-authored the book that just came out actually yesterday, Requirements Engineering State of Practice, the 4th edition. And more data from these surveys are in the book. But of course, the book will also discuss the best practice of requirements engineering. And each of these areas that I spoke about are explored in much more depth in the book, along with how requirements engineering is being shaped in the near future, especially with the emergence of disruptive technologies, how these are being challenged. So the book is available on Amazon, and it's actually the book that we use at Penn State to teach our graduate students the requirements engineering. So this is it for my presentation. I thank you again so much for the opportunity to present today, and I'm open to any questions.
Thank you very much, Dr. Mohamed. It was very useful covering all these disciplines about one of the most important phases of the software development life cycle, which is requirement engineering. And you gave us very insightful results from the surveys and recommendations. We are now open for any questions to Dr. Mohamed. Yeah, we have a question here, please. Yeah.
Yes, I'm here. Thank you, Dr. Mohamed, for your comprehensive presentation about requirements. I have a few short questions. One is that we are speaking in software system engineering about capabilities. We do not talk more about requirements, and capability is It's like a class where you have the functionality and the performance of the implementation of requirements to, which seems to me is like non-functional requirements. So have you seen in the software requirements and this approach?
All right. So, you know, with Carnegie Mellon University, with the Software Engineering Institute, when dealing with the non-functional requirements or quality requirements, there is a tendency to call these architectural drivers. So there are different terminologies, of course. They don't like to use non-functional requirement. While this term is being used in the requirements engineering community, architectural community would rather to use architectural driver. The reason is, it doesn't really matter if I call it reliability, it doesn't really matter if I call it security, it doesn't really matter if I call it availability. What really matters is how this requirement will be specified in terms of quality scenario, and how this quality scenario will shape and influence the architecture. A quality scenario, and you refer to a term capability, but a quality scenario should have 6 elements into it to express how this scenario is what will be the stimulus source, the environment, the artifact, and what will be the response, and the most important is what will be the response measure. So if the requirement doesn't really have a measure, if there is no metric associated, it's not verifiable. It's ambiguous. So this is how things are being paved when dealing with quality requirements. These requirements are being specified in terms of quality scenarios that should have 6 elements into it. And these scenarios eventually will be the input for an architectural process like ADD or SDL.
Okay, and another one is that, have you seen in the software community a tendency to accept, by example, SysML requirements modeling approach? Because to me, it's a little bit strange that we don't have in the UML a kind of SysML requirement diagram through which we can model the relationships between requirements.
Right. So basically, I've seen SysML is being employed not necessarily to express the entire set of requirements, only to express a specific portion of the most highly important requirements in a safety critical system. And only when maybe simulation would need to be employed, only when you know, the contract imply big fines if a failure would happen. So in our book, we speak about SysML, we speak about UML. I've worked in different companies in the past, including domains in financing, in healthcare, in telecommunication. I've never seen requirements being expressed in SysML, to be honest. But
okay,
you know, from our survey, I've seen that SysML is being employed on a very small fraction of our sample, and only in these situations.
And a last question, a short one. Which is your opinion related to the way we should understand the requirements? Should we need another kind of tools, like, by example, trees to discover the contradiction in requirements? What kind of, let's say, extra tools can we use, not only listing and reading the requirements, how to interpret them, how to find out the contradictions that we have to solve for a specific system?
This is a very big question. So there's no short answer to that. And basically the whole book that I've just listed, it's aiming to answer this question. So in your question, you mentioned something about requirements conflicting. So there are different techniques like AHP, when conditions, and there are mathematical approaches even to deal with requirements negotiation and requirements conflicts identification. But this is one trend. If your question means that what are the tools to analyze the requirements and find if I'm missing some aspects or to improve the ambiguity, then there's other set of tools. So it depends which aspect of requirements we are dealing with.
My question was about understanding the needs of the user from distilling that information, which is crucial for my system.
Right. So exactly. So we in that book, actually, in chapter 3, we've listed 23 techniques of requirements elicitations, and on average, there is no one single technique. It's sufficient enough. So that's what I reported in the slide, that along the four surveys, we've witnessed on average, a participant would select at least 3 techniques to capture requirements from the users. And which technique to use, it depends on the context, it depends on the type of stakeholders. So each technique, it addresses a certain situation.
Yes, thank you, Dr. Mohamed. And we have also questions from online attendees, so we will share on the screen.
So did you publish these results on the recent survey? Yes, it's an IEEE software magazine publication that came out in January 2022. The title of that paper, it's the same title as of my presentation today. So if you search for the IEEE software, the current and evolving landscape of requirements engineering and practice, and the paper is published there.
Yeah, thank you very much.